Yo, what's up, what's up, everybody? Welcome back. Today, we are trying to implement naive hardware acceleration for my GPU driver. So, context here is that one day we think it would be fun to make a graphics card, right? And in order to do that, we should probably have some feel for like what a graphics card does. And so what we've been doing in order to try to like disambiguate what is in software, what is in hardware, is we've been kind of implementing uh, a GPU driver from scratch, right? So we're kind of working in this world right now where we have like a virtual machine. His name is QEMU, right? And we kind of want to make it so that we can implement a little like PCI device that is called Sphero GPU, right? And this QEMU, this like kind of talks to like he renders some stuff in like the QEMU display, and we have like a kernel, and he implements like DRM, the direct rendering manager, I think, system for this PCI device. So the kernel like walks in PCI devices, he finds one with this PCI device ID, and he goes like, oh, that's our Sphero GPU driver. And we have like an example of this working. So if we go like test app dev DRI card 1, this is our GPU here. We see a few things here. We see like, yes, this is in fact a Spherophoria GPU, and he prints some interesting information about the buffer. But if we go here, we can see like, look, we're rendering some stuff, and he blinks and stuff. And this is like our app that we wrote by hand. But also, if we use like existing applications that are not ours, for example, KMS Cube, we can do the same thing, where he uses OpenGL in a software implementation of OpenGL to render this cube, spin it around, right? So we have like a really basic driver that kind of works for like 2D, right? So we have like a frame buffer, and you can write pixels into this frame buffer, but that's all we can do right now, right? And so if we want to understand what a GPU actually does, we have to do more than this, right? So we kind of like the typical software stack here is like OpenGL, right? He calls into like an OpenGL implementation, which is usually like driver specific, blah blah blah. But like on Linux, it's kind of like a lot of drivers are all implemented by Mesa, right? So I have like an AMD graphics card, and the AMD graphics card is like uses an open source driver stack. So the AMD goes through here. Like there's like an AMD driver in here, right? There's also like an Intel. NVIDIA kind of does their own thing. And so these guys kind of talk directly to like an AMD kernel driver in like kernel, right? Or like an Intel kernel driver, right? Intel, right? So what we're doing is we've kind of made our own thing, Sphero. And like if we were to draw an application that renders stuff with OpenGL, he would have to have some sort of implementation in here. Now we don't really know what that's going to look like. The goal for today is to not actually make this thing, but to try to just make something, right? Cut this guy out of the middle and basically just talk to the kernel driver directly and figure out what would we do if we weren't constrained by Mesa and like existing OpenGL implementations or OpenGL in general. What would we do if we just wanted to render this, right? So this is our little like example app that we've written in OpenGL in our like Wayland client recently, right? It's just like one model, a simple object parser. He throws the vertices onto the GPU and then like textures him and applies some transforms to him, right? It's not crazy. There's just like a camera transform in here, as well as like a model transform. Actually, I guess like from the perspective of our OpenGL app, it's like one transform, right? So I'm kind of want to play with the idea of like, could we get our graphics card to basically do this same application just without OpenGL? What does it take for us to like upload vertices to our GPU and like transform them with some model matrix? Like what does that mean, right? And so that's the goal for today. So I think the plan of action is approximately store the model in GPU memory, right? Take this model, put it in an application, upload him somehow, some way. Then we want to set up an OpenGL render context in QEMU. That doesn't sound right. Oh, right. So on the host, if we are going to render this thing with OpenGL on the host, then we have to like make that OpenGL context, then like actually render the model, then like texture him and apply a rotation. That's kind of like, broad strokes what the plan of action is. And let's just kind of get going. Let's get moving and grooving. And if we have a successful stream, I guess we shouldn't quantify success as if we get to the end. But if we get to the end, we will see this just rendered on our virtual GPU, which would be cool. Now, I will note that technically we can do some 3D rendering on our virtual GPU now. It's just that 3D rendering is done entirely in software in the guest machine. I would like it to be done in OpenGL on the host machine. So I would like to clarify that is kind of like the difference here. Okay, so how do we store a model in memory? I don't know. My understanding at this point is we've been kind of like looking at vergl, which is like this basically OpenGL pass through from a guest to a host. They have examples here on like doing things like transferring data to the host machine, and so I'm assuming that we're going to be doing something along those lines, right? My understanding of like the graphics stack in Linux is that there are kind of common things that you expect all drivers to be able to do, and those are defined in DRM ioctl here. So if we go to like wherever they jump into this table of ioctls somewhere, where is it? We should be able to see the table pretty here. So all of these things you like expect to be available for all graphics cards. Things like get the version, right? This like allows you to basically ask for like what GPU are you and like how do I then let's switch behavior on that, right? Or things like there are things like DMA buff, which lets you share graphics buffers between things. These are kind of like implemented by like the generic API, but then there are like specific things such as how do I actually interact with the GPU specifically for my case. So how do I say that? I kind of just said it's specific, which is not very helpful. So like you can imagine, I don't really know what actually goes on in this cloud of shit, right? That's kind of what we're trying to find out. But I imagine that you might have like your GLSL shader, right? Vertex shader. This is like a thing that you have that is in like text, right? He's got like int main type shit in him, right? This I think goes into some sort of like compiler that will turn this into like bytecode that can be uploaded to the GPU, right? So there's probably some sort of like user space component that turns this into like AMD like bytecode, right? And this the rules for how you upload this are going to be like card specific, probably, right? And so the AMD card might provide an additional ioctl that's like AMD upload a program, right? Kind of hand wavy. We're kind of glossing over all the details because I don't know any of them. But you can imagine that there's something like this, right? And so, like in the Vert GPU case, they have examples of like, oh, we're gonna like allow you to transfer data to the host machine, and here's the call to do that. And I think that what we're gonna do is we're gonna follow this model, and we're just going to add like APIs for our specific driver as we need until we get to the point where the thing renders. That's kind of my feeling. So I think that we're probably going to want to basically take some inspiration from here. So they have ioctls and num ioctls set here, and so we probably just want to do the same thing in our driver. Right? So we want to do like, boom, Sphero GPU ioctls, and Sphero num ioctls here. Where is this DRM vert io num ioctl defined? This is defined in their header, so we can kind of just define that where the fuck we want. Define DRM Sphero num ioctls, okay? And we will say for now we're gonna have one, and it's gonna be put this thing on the GPU, right? Sure, fuck it. I don't know. And then they have this implementation of a list of ioctls. So I guess we say here are our ioctls. And we are going to have, this many of them. And I guess in each one of these, we define some name of an ioctl. So like, where does this come from? This does DRM ioctl vert GPU map. So does that have to be defined somewhere, or does that get defined here? Surely, right? He's asking for a number of DRM ioctl It's confusing. That's not a number. That's not a number. I'm confused. Did I read this right? He defines a number here. Helper macro to fill in struct this thing. Command number is constructed by prepending drm octal and passing that to drm octal number. Okay, so I guess drm octal vert GPU map is what goes in here, right? Yeah. Which goes into this thing, which just like fucking shifts a number. So like, how is that possible? If this thing isn't defined, I'm like very unconvinced that if we do this here, that it will work. I'm very unconvinced, but we can always try. We can always try. So here, yeah, right. Use of undeclared identifier. So there must be some sort of like DRM ioctal definer somewhere. So can we look for like a exec buffer just kind of on its own? I feel like I'm losing my mind. Oh, here. Here we go. This is what we're looking for. This is what we are looking for. So here we're going to define our DRM ioctal. I guess it's like Sphero upload vertex buffer, right? That's kind of what we're going to call it. So here they have DRM vert GPU exec buffer. Okay. So I guess we call this Sphero upload VB. I guess this is how this works. We're not going to ask too many questions. And this gets Sphero upload VB. I guess this stuff is living in like userspace API mappings, right? So this stuff is supposed to be available to userspace. So I guess it makes sense for us to have Sphero drm.h here. Kind of just makes sense. And it looks like both of these things are defined in the userspace API header. Sure. So this and this live in here. Probably want to do like a pragma once. I'm sure that this isn't how kernel does it. They do if-def. If and def, Sphero drm h. We define it, and then we end-def. Like this. Like this. All right. And I guess this is a reasonable thing for us to slap in there as well. I guess. And then it was also reasonable for us to include DRM. Or else it won't work. Boom. All right. All right. So now in our driver, I guess we include UAPI DRM Sphero DRM.h. And then this hopefully just kind of works now, where we say upload VB, and this goes into Sphero GPU upload VB ioctal. Okay. He's mad. Oopsies, what the fuck did I just do? I pressed Control 0, which resets the font size, which is no good for you guys. You guys get mad when I do that. And then we have to implement this function. Does he take the type here? Also, we need a type for the command, so it's going to be like a DRM Sphero upload VB, which means that we need a structure for that, right? Right. And I guess what it's gonna go in this thing? It's gonna be like data and like len, I think. I think you do underscore underscore u64 in these user space octals, I think. We can take a look. Yeah, they do like underscores like this. And using gem handles might make sense here. Might? We could do it that way. It's kind of how they're doing it everywhere. Although I don't really know why. Yeah, I'm not really convinced that that's right. Also, like, how do they like write data to these things? I guess they just mmap them in, right? So we can kind of say that we have like a gem buffer. We mmap it in. We write to it. Okay, sure, yeah. We'll use handle. We'll use a handle. Fuck it. Fuck it. So we'll just say upload this thing. Upload this thing. Which might mean that we are going to have to add an API to like create one of these as well. I'm not really sure. I think I read somewhere that like the creation of these gem handles, the like user space, GPU, kernel space, shared memory thing. I think I've read that the creation of those is typically driver specific. But we will find out. We will find out. Yeah, let's start here. Let's start here. So, somebody calls this. He's mad probably because this function doesn't exist. And I don't really know what like the function signature of this is supposed to be. Probably like I guess it'll probably tell us. He's actually mad about undeclared identifiers. So what's he mad about? What's he mad about? Let's just give him a chance to bitch and moan. Okay. Jeez Louise. Okay, so DRM octal, not a function. That's cool. Okay. So this is defined in drmoctal.h. Seems fine. Okay, I'm gonna come back to this, I guess. Let's just try to get compiling it all so that we can narrow down the problems. Narrow them down, baby. Okay, so this is just unused now, which is fine. Which is fine. Okay. So can we go back to vert GPU derv, I think is what it was called, and they had their like ioctal table. So this is defined in DRM ioctal. This has a function signature like this. Who takes in these things. That's fine. Now it's just what are they complaining about? Because upload VB. Oh, this should be Sphero. Upload VB. There we go. There we go. That's much better. Okay, what's he mad at now? What's he mad at now? I swear, Crimson Dawn, unless my peripheral can read, I got to it first. But if not, my bad. You can get the credit. So he's complaining about array index in initializer exceeds array bounds. Does it? What if I put like 2 here? Okay, so that's fine. So does it have to just be 1 plus? They say 12. What is it? Is like vergl, vert, uapi, vert, drm. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, it's just 1 plus, huh? Looks like it's 1 plus. Just by going off that. Which is, I guess, fine. I guess that's fine. Feels strange to me, but you never know. I guess maybe they need like a null one at the end or something to mark the end of them or something. Who knows? Who knows? No, I'm missing something here. So they say drm command base. Oh, I see. So if we made our octal number 0, maybe it would be fine. But maybe it can't be 0 for whatever reason. Sure. Okay, whatever. So I guess now we are going to have to try to do something sane here. So they're going to have to like allocate a buffer, write some data into it, and then try to upload it. I guess we're going by handle, which kind of means that we should probably make a new one. What do they have? Like resource create, right? They have resource create, which is probably the workflow. They probably create a resource that gets them a handle. Yeah, unless there's like gem ioctals that can do this for us. So can we look at DRM octal? It's where does this come from? It comes from the fops. Here we go. Gem shmem fops here. Yeah, so it's literally just this. Where's the table? Yeah, so it really does look like they don't have memory creation, which just kind of lines up with my understanding here. Lines up with my understanding. What does like this do? Open. If we try to open an object, opens an object using the global name, returning a handle and the size. Okay, sure. Understood. Okay, yeah, fuck it. We'll just make an allocate. So this is going to be something like create resource. AMD GPU driver has an octal value of 0. Not sure why VirtIO skips it. Okay. I'd be willing to try that. We can just kind of do that now by going into here and we'll say create vertex buffer. Gets value of 0. That means that we need this, which gets this and this. Okay. So what are our creation parameters? Do you think that we pre-allocate the size? Or do you think that we can like figure it out as we go? We probably have to pre-create it because there's an mmap that call that comes with this. Probably, maybe. So this is probably like an output parameter. Output handle. And then maybe we take like a size in. So maybe we'll do like inputs and outputs. That seems reasonable to me. Seems reasonable to me. So we are going to define this create VB, which is going to call create VP. I do want to follow the naming scheme, so we'll say VB ioctal here. And now we can actually do something. So we're going to say struct sphero create VB star is real data. And I guess this is the params. We are going to have to do some sort of like derm gem shmem create here, which we did over here. When we do like dump buffer creation, we do the same thing. So we're going to create a handle out of this thing. I guess this is just going to be very, very, very similar to Sphero GPU dump create. Maybe identical, even. It really does feel that way. So maybe this gets turned into static int Sphero create gem shmem with the struct DRM device dev and the size, which I guess we'll just follow the arguments here, which we can't index unless this is syntactically correct. So we'll do this for a second. Now this should allow us to check the inputs here. So it's size t. And then we just kind of take this stuff. We say return Sphero create gem shmem dev and args size. And I think this stuff can all just kind of go like this. Boom, 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 boom. Where did file priv come from here? I guess we need that as well. Struct DRM file star file priv, boom. And this is going to return a handle. All right. Sure. So this now takes in file priv and args handle. Bing, bang, boom. And now we can just do the same thing here. So this takes in file params size. And I guess this comes from params handle here. It's actually just the same shit. Same shit. All right. So I guess from user space now, I guess we're going to like allocate a buffer by calling this ioctl, create VB ioctl. And I guess we will try to mmap that thing from user space, which I think should just kind of come for free. I think that this guy, we'll see. I think like this guy implements mmap somehow. Maybe the gem object in it. Not sure. We'll hope. We will see. I think that how do we do this for our existing application? We do in fact mmap a thing in here. So we create a dump buffer and then we map dump buffer. There's a specific call to map the dump buffer and give it a location in the file descriptor for a GPU that we can call mmap on. So surely we must do the same thing here. And I bet that if we look at the driver implementation for vergl, I bet we will see them have some sort of mapping ioctl, right? And this is probably going to take in a like handle to map and an offset that is probably an output. So they're probably asking for a mapping with the output offset. Yeah. So they take the handle. They basically just look up the thing and they set size offset for user space maps. How do we do it in our GPU driver? Map. Dumb. I'm missing something. So it's DRM mode map dumb buffer. Map dumb. So this goes into some driver specific thing, which we did not implement. I see. So if this isn't implemented, what happens? It just calls return the fake mmap offset for a gem object, which calls create mmap offset, right? So if we don't have that thing, then we're probably going to be in trouble. Probably. However, they don't call create mmap offset in the vert GPU stuff. It's kind of surprising. Seems like this will have to be done somewhere. It's called here in GPU VRAM create. Gem shmem create. Oh, does it for you? So he just has an mmap offset. No matter what. Every gem shmem object has an mmappable offset already associated with it. Okay, sure. Sure, seems reasonable. So we will just kind of live with that. Yeah, so we that means that we don't have to do anything here? No, because we still have to be able to call the mapping. Because they only have map dumb. Which I guess is not guaranteed that this is dumb. So I guess we'll just call this map. And we will say Sphero GPU map. Okay. Which means that we need to implement these, which means we go to Sphero UAPI. And we have a new one that is, I guess it should go create map upload, right? Great. Surely this is like something that we should macro, right? Like gen drm ioctl. Fuck it, I don't know. I guess we'll do what everyone else does, even though it feels stupid. All right, which means that we need a map VB. And this is going to be inputs handle, outputs offset, right? That's what it was in the other example. That's what it was in the other example. All right, we're chilling. Big chilling. So we have Sphero map VB is what we called it here. And then we just need map VB ioctl. Like this. And this needs to be incremented to 3 now. Wow. Wow. All right. So the map is just going to basically call like lookup offset. So we're going to do the same thing that vert GPU did. I think. I don't think there's any reason to do anything different. Right? So they just call look up the thing and where the fuck are we? Just literally the same. Literally the same. So we have struct drm map VB for a vertex buffer. We call this with file params handle. This is a struct diagram gem object star, probably. What does this return? Yeah. This is a reasonable return for that, and then this goes into params offset equals this. Wow, simple. Simple, 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 really. Okay, so now the trick here is to like prove that we did something here, right? So maybe we go into our little test app here, and we will, once we get initialized, it's probably fine for us to just kind of like down here somewhere be like, we need the header. We need the header for our GPU stuff, which we don't really have right now. So maybe we need to update our build zig to add a system include path to source Linux include UAPI or something. I don't know if it's fine to do this. And then we might be able to do like C include UAPI sphero drm.h or something. UAPI DRM. Okay, that seems to work okay. And then we should be able to like use this to call that like create buffer things, right? So where the fuck we were trying to add our stuff, it should be something like a octal, C octal. Is DRM octal a stupid thing to call here? Maybe that's fine. What does this do? This is probably like a wrapper for DRM octals that is implemented in libdrm. Probably. Probably. I don't know. Don't ask me. Build root, build libdrm, DRM octal, int DRM octal. There we go. Yep. So this is in xf86 DRM C. All right. Sure. Fuck it. That seems reasonable. Seems reasonable. A little restarties. So we call this with DRM C, DRM octal, sphero, create vertex buffer with our params. Okay. And then I already forgot, does DRM octal here, does he return Erno? Oh, he returns ret. Okay. Okay, sure. So var create VB params is going to be something of type C DRM, I guess sphero, create VB, yeah. Create VB params dot size is going to be like, let's make it like just like 100-byte thing just for now, just to see what happens. Okay. VB size is equal to 100. If this is not equal to 0, we'll return error. Create VB. Cool. Otherwise, we will continue on and we're going to try to map that thing like almost immediately. So we're going to say like DRM octal sphero map VB, and this is going to be map VB params. It's going to look very similar. But it's going to be called map VB. And here we're going to say map VB params dot handle is equal to the output of create VB handle, right? then we should have something we can mmap. So we should be able to do like VB data is an M mapping of the VB size that we asked for. Readable and writable seems reasonable given our handle to our GPU and using the map VB params offset. And we should be able to do like this should be call this pointer. We'll say const VB data is equal to VB data pointer from 0 to the size that we asked for, and then can we just like memset that thing? This fills all elements, so like just like fucking like white that shit out. And if we white it out, hopefully like nothing should crash there. That's kind of the goal here, right? Is that this mmap succeeds, and it succeeds, and we fill this thing with data. And I guess after all of this, we'll probably call upload VB. Which is going to look like this. Okay. And what happens now? This guy probably just has the handle, right? So it's going to be more like this, and handle is equal to create VB params handle. Wow. Wow. Okay, so I think that should work. Is it build? Okay, and I guess probably what we want to do here is in our driver, to prove that we got what we wanted, maybe we will try to look up the object from the handle it gave us. Of course, we need to clean our handle up. We need to say that our params are in fact our upload params. Okay, and then can we just like print what's in these? So I guess we'll say for int I equals 0, I is less than. Do we have the size in this thing? Size, we do. We do. So we can just go g_obj size. Can we like look at the data in this thing? We probably have to like extract the shmem object. Right, so we kind of do like this. And then can we look at like the actual fucking data in here? Page table, SG table, virtual address of the backing memory. Can we just look at this? Probably. So we'll say uint 8 t star data is shmem obj vadder. And then we should be able to just look at the data, right? So we should be able to go if data I is not equal to 0xff, I guess we'll just say bug on this. That's not good. We don't really want to crash our kernel in that case. Hold on. Looks like the rest is fine. And then data, he doesn't like this. Oh, because data already came in. So we'll call this buff date. Buff. Boom. Print k, not full white buffer. Okay. So if everything is correct, we should see. I guess we kind of want to do like this. Full white equals false, and then print. Is full white question mark? Here you go. There we go. That feels like a good way to test. Feels like a good way to test to me. Let's build our kernel. Hello, brother. Hello, brother. Here I am at Camp Granada. That's I don't even know. I don't even really watch The Simpsons, but my friends really like that scene from The Simpsons where they call and they say they're at Camp Granada. I don't know what's going on, but it's stuck in my head. It's really deep in there. Really deep in there. Okay. Yeah, so we have created a buffer, mapped a buffer, hopefully filled it, and then hopefully we try to commit it. I wonder why he's rebuilding the whole kernel again. I really feel like he shouldn't be doing that. But, you know, we live, we don't learn. And let's run this thing. I guess we need to probably need another environment here somewhere. Hello Moda, Hello Photo by Alan Sherman. That sounds like it. Okay. So here we do this, we go here, we go here, we turn on networking. Here we go. And then we zig build and do all this shit to SCP it, except we want card 1. And it looks like it kind of worked. Oh no, he crashed on upload VBI octal. So it looks like it wasn't safe for us to just look at that. It looks like we didn't crash in the application when we tried to write that memory, but trying to like poke that memory just by looking at that void star was not really valid, it looks like. So where does this happen? We probably need to create, probably have to call this first. Surely. Is there an example of someone calling this? Object vmap. Drivers that employ the shmem should use as their... okay. Is there an example of someone calling this? Map? Where does the map come from? Like, I guess this is not the way. That's kind of what it's looking like. Looks like this is not the way. We have done something before where we go, we might as well do it the other way. So, I don't really know how I'm supposed to do this, but it's fine. It's fine, it's fine, it's fine. So, for each scatter gather, it looks like we're supposed to do maybe, I don't know. For each SG table. For each SG table. Maybe that's what we're supposed to do. So we have like a scatter gather list. We can, I guess we have to get the scatter gather table. So we kind of do it this way. Something like this. Something like this. Then we loop over that thing, which I guess we can just do the same way we're doing here. Stuff is prepared for DMA, I guess. And what we did last time here, was we extracted the virtual address. So we just did like a SG vert So we'll call this like page adder is equal to this. And then we do this same loop, but we do it on a page by page basis. And maybe he will like that better. Maybe. You never know. You never know. So this should be page adder I, and this should be coming from the page length here. There we go. Let's try that. Let's try that. Hey, I want to say around thank you for the amazing content. Hey, no problem, man. No problem. I am just kind of doing what I feel like doing, and it's nice that other people can get enjoyment from just watching it. So I'll be doing this shit anyways. It's what I find fun. All right. Let's see how broken this is. Is full white 0? So that's not good. That's not good. Here he didn't crash, but he did not behave the way we would hope he behaves. It's not ideal. Not ideal. I wonder why. Can we count like how many bytes we looked at? Okay, so num bytes is num bytes here. Let's start there. I guess we should just use our tools, huh? We should use our tools. So how do we do this? We do, instead of recompiling this thing, I guess we will recompile it now just because we already have changed the source code, but in reality, we should have been looking at the memory with GDB. Right, so where is our run station? Here we go. -s for run with GDB, please. And then in another window somewhere, we go into build Linux and we look at our run GDB script and we adjust the breakpoint to be like here. But we can't really do it that way, actually. Can't really do it that way, so it's fine. It's fine. GDB-x run.gdb, continue. He should be relatively happy now. We can hit a breakpoint or hit alex symbols to load our kernel modules in and then breakpoint on this file line. And now we should be able to go test app dev dri card1. We breakpoint, nice. And can we print page adder at 10? Dereference. We do see a bunch of 377s. What does that mean? Is that fucking base 377? Is that what I'm looking at? That's so weird. Why would you write it this way? Oh, they're trying to show individual nibbles, maybe? That's very confusing. But it does look like it is pretty full of FFs, right? So it would maybe be interesting to breakpoint on here and see in which case that's happening. Did we print? He printed 4,096 bytes. Oh. Okay. So that's a clue. That's a clue that, like, yeah, that's weird. Right, because we tried to only allocate 100 bytes of this thing, I feel like. I thought. When we created this thing. Let's see what happens here. Size. is page aligned. And then how do they like round it up? Page align. So what am I looking at here? Yeah, so it looks like they have like a minimum size of 4096, huh? It looks like they're like aligning the size to be at least 4096 long. Don't you have to iterate over that page? How does that work? I think I did do that. Here we're going for each page, pull the virtual address of the page out, add the length, and then iterate over the page to check if we're full white or not. So maybe you're, for some reason, it like, Robobototo? Fuck, I wish that when I dragged pages over it, they fucking ended up in the foreground. But he says, maybe you're, which is like, I guess like kind of correct. Right? You are? It's just, it's weird seeing the contraction at the end of the sentence. I've just literally never seen that. Even though I don't see any reason why that's not correct, it feels so wrong. Which is kind of funny. Okay, so it looks like our flaw here is trying to use the allocated object from shmem. It's kind of like approximately how it feels. It's fair for you. There's a Tom Scott video on this topic. It's quite interesting. On the UR. Yeah, it's weird because I don't see any reason why it shouldn't be right, but all of my alarm bells are going off. I'm like, what the fuck? That feels funny. Stupid English. I'll look it up later. It sounds fun. Okay. So I guess we just on upload probably need to just track the size. Right? We say like, hey, our thing might be oversized, and so you tell us what size you think it should be. English is not my first language. Yeah, I mean, I'm not trying to roast you in any way. I'm like looking at him like, I don't see why what you did is wrong. So that's why I'm like, I'm not saying like you did something wrong. It's just like, oh, that's weird that it's not okay. Okay. So I guess when we upload, I guess it's fine to do the full page, to be honest. It's just that we have to tell the host side that there's maybe too little stuff in there. Video titles there didn't have nice. Nice. Yeah, I think that I'm like pretty content with the fact that we successfully got data into this thing. I'm not too content that it is a 4096 minimum size. I'm not sure how I feel about that, or if there's some better mechanism to do this data transfer. I wonder if we have to use a gem object at all here. Right? We could just fucking slap a like void star in somewhere, but I guess probably using the gem stuff gives us the advantage of like having all of the buffer tracking and stuff come for free. So maybe we stay that way. And also it kind of matches the expectations of other drivers. So I think we will keep using the gem object here. And I guess a vertex buffer is maybe going to be big sometimes. Fuck it. This is probably fine. Okay. So if now we are going to have to send this thing over to the GPU. So I guess we have QEMU open. I guess we add a new register here. That's going to look very similar here. It's just everything here that says frame buffer is going to say vertex buffer now. Right? So in the same way that we had a bunch of frame buffer addresses that we kind of like push together and then commit as one chunk, I think we'll do the same thing here where we have a bunch of vertex buffers that we push with varying sizes of different pages and stuff. And then we commit, I guess it's just called VB commit. So this becomes 6, hello, 6, 7, 8, 9, 10. And then here we do the same thing where we kind of stash this stuff as it comes in. Okay. Then I guess we probably want to write functions here, or at least little function-like macros that say like extract low, extract low. Yeah, and that's basically gonna do this. And I guess it's not just extract low, I guess it's going to be like replace low. Yeah. So this is me a void function that takes in the output parameter and unit32 t star input parameter. Yep. Seems reasonable to me. And this is just me like out like this. And we're gonna have replace high as well. Which does this. I'm sure there's probably some more efficient way to do what I've written here. But, you know, shut the fuck up. And I guess this is now kind of like unit 64 t in u64 is in. I'm not 100% sure on the casting rules here, so I'm going to do it this way. Just because I'm not 100% on it. Just I'm not 100% sure. So now this becomes replace low. Oh my god. With data and sDMA address. This becomes replace high. Data shifted. Data comes in. Yeah, it's like this. Replace low. Data and DMA len. Replace high. And I guess we kind of just follow the same pattern here for VB. And then DMA address becomes, what was it? What are we working on? VB address? Oopsies. Oh god, what am I doing? VB address, VB address, VB len. And now this do DMA is going to take in a input and output probably. Probably. So this takes in like an address. Okay. We'll call this in address for now and inlen because we are overloading those terms down below. And we are going to pick an output for those things. Sorry, I'm thinking. So before we were kind of tracking the pixel position here as well. So maybe here we return the number of bytes transferred, although we kind of can assume that we transferred inland bytes. It seems like we can kind of assume that. So here we go to out plus written. Hold on. This gentleman's like just banging on a door outside. But I think it's fine. Okay. So I think this becomes in adder here. This is, I guess we look for anything that says like S address here with in adder and S DMA len with in len. Okay. Then what? Then what? Then I guess. Hey, it's okay, bud. It's okay. Sorry, my dog's not happy. Wait, one sec. I'll be right back. All right, sorry. All right. Chair solves world peace. Okay, what are we supposed to be doing here? We are trying to make sure that the output tracking is fine here. So when we were copying pixel by pixel, we are now going like do DMA. We probably don't take in our state here at all anymore. This stuff doesn't need to be done anymore. This like counting pixels. This is not necessary anymore. Hey, Ginger, come here. Come here. Hey, one sec. Yeah, she's good. So we copy to out plus however much we've written to here. So I guess this doesn't go to out. This goes to adder. So adder here. No. This goes to out plus however much we've gone for. So we'll say like uint 64t written is in adder minus it's adder, right? This is how much we've written, because this thing is no, adder minus in adder. Yeah, this way. Okay, so this is how much we've written, and so that means that we can say that out plus written gets this stuff appended to it. That seems right to me. All right. I think that's probably right. I'm not 100% sure that we had this right, so we're going to have to be a little careful here. So probably what we do here is we just do now do DMA with the right crap parameters. So what are we trying to put into the pass in here? In adder, which is s DMA address, s DMA len, and the output is going to be into s pixels at display index. And then here we do s pixel right index plus equals the DMA len over 4. I think that makes sense here. I think, which means down here we can do something very similar, where we go to VB address VB len, and we try to write into our what do we do here? We probably have some sort of like vertex buffer. And probably here we do something like if this exists, we free it, right? But if it doesn't, then we allocate it. Yep. Then we copy into it. That seems right to me, kind of hand wavy. The commit frame goes here. And I actually forgot this is not true. This is not true. Because this is this could be happening, like this could push multiple pages. So we kind of need a same thing here where we have like how far into our thing we are. And then we have to do like this. And now I don't really understand how are we going to malloc it? I think that we will do this stuff if the address is null. I think that's kind of like the cheat code here. So what we can do here is we can like basically on the first run, we'll write 0 to the address, then the size of that we expect to transfer. Then we will do the transfer by shoving like page by page in. I think that makes sense. Which kind of makes it seem like we don't need a cursor. Or sorry, we don't need a commit thing. I guess we kind of... Yeah, I don't think we need a commit right now. I do not think. Not really sure. I guess we'll leave it in here for now, but I'm not 100% sure that we need it. Depends on what we're going to do with the vertex buffer when we upload it. So I guess this stuff goes into the Linux side. I guess. Whoops. Like this. And then in our vertex buffer transfer, we're going to do something very, very similar to this, right? It's going to look very similar. So in the same way that we were uploading frame buffers before, we now are uploading our thing. So we need our private data here. So I think our struct sphero priv comes from dev private, which means that now we have regs here and just everything here goes from sfb to vb. Okay. And we did say that at first we were going to write out 0, 0, and then the size of the total size of the thing, which is going to come in from our upload params. Right? I guess this should be U64. It should be U64 here too, to be honest. Okay, sure. So far, so good. So far, so good. Anything else we have to think about here? Probably not. Probably not. So now what? I guess in the QEMU side, we should be a little bit defensive here. And we can write VB len here. Maybe like allocated. Yeah, it's confusing. So we'll call this like len field in VB upload registers, and we'll call this like size of allocated VB. Otherwise, it's confusing. So I guess here we just need to make sure that when we do these DMAs, that we're being a little careful, and we can say like if VB len is greater than S VB size, we do this. This needs to be like plus S VB cursor, right? So if S VB cursor plus this is less than that, then it's good. And we do the same thing probably here. If S pixel right index pixel right index plus DMA len over 4 is less than or equal to pixels len. We can do this. Okay, that seems reasonable so far. Yep, okay. I'm willing to fucking pull the trigger and just see what happens. Willing to see what happens. Make kernel as well. And let's just hope that nothing is so unbelievably broken here that it doesn't work. I don't think we need, I don't think we need to run a GDB. I don't think. So we turn that shit off and we run it. Let's see what happens. Test app dev DRI card 1. Okay, so he didn't like create VB, surprisingly, but he did end up actually drawing something here. So what doesn't he like there? This used to work, right? We used to be able to create, map, and upload here. Oh, maybe the sizes, I need to recompile and re-upload because I changed the size. Yeah. I forgot. We changed the type in the userspace API, which is bound to cause problems. Okay. All right. So this is fine. So it looked like everything kind of worked. Now, it would be nice to have some sort of proof about what we copied over. So maybe we can do if SVB cursor is greater than or equal to SVB size. Can we print out what we got here? And maybe we'll add a couple prints here. Like this should say allocating new VB of length this. SVB len. Okay. Here we will say, I guess we run this shit, right? So we go like for int I equals 0, I is less than SVB size, plus plus I, SVB at I. If this is not equal to 0xff, we have a problem, right? Printf not ff. Otherwise, We'll print like a done here. And I think that will give us the information we need. That'll tell us if we successfully uploaded our vertex buffer. Man, printf's so fucking stupid. Like, I understand why it is the way it is because like variable arguments to a function don't have types, and so like it has to figure out like the size of the element on the stack based off of the printf argument, and then the compiler tells you if you got that wrong. But it's like, this is stupid, right? Like this, like if the compiler knows, then the compiler should be able to figure it out. But I get it. I can just be better. I just don't see any logs there. Just kind of surprising. Right? We didn't see this. Can we print out VB len? Like here? And then also like that num yellow, num black thing needs to go away. Yeah. And I guess we probably have to initialize this stuff, huh? I guess. So we probably have to do like on realize at the very least. We have to do s vb equals null. At the very least. All right, let's run it again. Boom, boom, boom. Root dev test app at dev dri card1. Yeah, it's very strange. Very strange. We're just seeing nothing. Nothing at all. Did we build the kernel? Looks like it. Can we, like, I guess just breakpoint here or something? I guess we need to. Build Linux, GDB. We run, we GDB, we continue. We wait a little bit for our thing to load. Okay, we LX symbols, and we breakpoint here. Continue. All right. Test app, dev dri card1. All right. So it looks like we got past there. And we are writing these registers. Oh, fuck. The memory map size is too small. We wrote 32 bytes here, so we need 64 now, I think. Do we need to adjust the size somewhere in the QEMU side? Here. Yeah, so here we should be able to say like, we have 10 times 4 is 40, so we'll do 64 for now, and we'll just mirror that here. So everyone should be happy. Everyone should be happy. Yeah, so what's happening there is like the PCI card advertises like the size of its like memory mappable region, and then we map that size, and then we were just writing past the mappable range, and somehow not crashing there, which is kind of surprising to be honest, but you know, whatever. All right, let's try this again. Root test app dev dri card1. There we go. Okay. So here, we actually have to clamp it. So the VB len is for 1 page, but that's larger than the amount of allocations that we've done. And we just kind of like reject the write in that case. We should clamp it. We should clamp it. So here we should say like, first of all, is everything else working okay? Yeah, this is still working fine. Okay. So here we need to do something like fix me clamp right len. I don't really care about this for now, but we can figure that out later. So here we need to go like uint 64t read len is equal to the minimum, which I assume we have here. Yes, maybe it's undeclared function of we want like s vb cursor s vb size minus the vb cursor or vb len, whichever one of these is smaller. Whichever one of these is smaller. Min doesn't exist, so define min ab is a less than b, a else b. We don't have to get crazy. We don't have to get crazy. All right. Oops, ninja. Ninja. Let's fucking run them. And hopefully this time we run a little better. Oopsies. We don't need GDB anymore, I don't think. Slower to boot, so we turned it off. And let's see. He does write done there. He does write done here, which makes it seem like we did read all FFs, I guess. Right? Because he got through this. Cool. So it looks like we've uploaded our vertex buffer. It looks like. Now what? Now what? I guess we want to upload a sane model, right? So maybe we set this up now to upload the vertices given to us. We'll say like upload monkey vertex buffer. Does that make sense? Is that the next thing that we want to do? Yeah. I think so. So let's do that. Let's do that. Okay, so what's the play here? We basically take our existing little test application, right? This guy. And we basically pull out the code from here that creates the model. So we have this like model renderer thing as well as some resources in here. And the model renderer will like parse out the object and stuff. So I guess we kind of copy this stuff into our little test app. And then in here, in our model renderer code, we probably just want to kind of start like ripping out anything related to OpenGL. Right, so we want to do like this goes away, this goes away, this goes away, this goes away, this goes away. Probably. Actually, how much can we get away with here? Using like dead code elimination and Zig. If we just like make this model type public, and then somewhere we like find all the vertex buffers and the vertex IDs and the UV IDs. Here we go. So I think we just like make like this public, or we kind of like adapt this a little bit. to be like make upload vertex buffer. This can return a std array list of u8s, or maybe like a u8 slice, maybe an f32 slice. Kind of makes sense here. This kind of makes sense. So we'll kind of like take this code here, where we basically walk our model, we kind of swizzle the things into like a XYZ UV vertex format. I think we can just return this thing. So return try vertex buffer to own slice. Boom. Okay. And then we make this public. We make the model public. And then I think dead code elimination gets us like a long way here, so that like all the OpenGL stuff just like won't be a problem. Maybe. There's only one way to find out. Model renderer is equal to import model renderer. Sick. All right. So can we call just like model renderer model load, and he wants this to come from the file. So can we like const model obj is this, and then we can call, kind of like hack this shit externally here. Right, we kind of do this. Nice. We don't have an allocator yet, so we'll just make one. Var, oopsies, the fuck did I just do? Var GPA is equal to std heap general purpose allocator with no parameters. And we would defer a GPA deinit. Okay, and we get the allocator out of the GPA, the generic interface for the concrete implementation. Then when we load our model, we should be chilling. And we should have like model renderer, like make upload data vertex buffer or something. Okay. So here we're gonna have like var const vertex data. And then this is also a triable function. We defer alloc free vertex data. And when we create our vertex buffer for upload now, this becomes the size of the vertex data. Right? So this is len times 4 essentially, right? And then when we memset this thing, when we try to set the data for upload, this is now a mem copy into VB data, but now from std mem as bytes, the vertex data here. Right? Something like this. Something like that. I think that's fine. I think we will see. We will see. So can we do zig build here? He's mad because those imports are not found. That's fair. Okay, so we do need to kind of get some of this shit out of the way. That's annoying. So all of these things actually need to get resolved. It's annoying, annoying. Yeah, it's really fucking annoying. All right. Can we like kind of like just keep going on commenting stuff out? Is it really? Oh, it's so annoying. I guess we can just kind of comment out. We don't need to comment stuff out like individually. We can kind of comment out like full functions, I guess. That makes a lot more sense, to be honest. Way more sense. 398. Yeah, so kind of just like all this stuff, we don't need it. This is what we get for copy pasting code. We do want this function. That one is important. And then model. He has no D in it, he says. Oh, because I wrote const. Okay. So now what do we expect to happen here? I guess we expect like vertex data to show up in the host machine in QEMU. Right, that's kind of what we expect to see. Okay. So what do we do with that? How do we prove to ourselves that this is like sane? I guess we'll just run it for now and kind of see where it goes. I assume that we will get like a write log in the QEMU output. But here we don't really see anything like much more interesting. Oh, because I didn't actually change the application. We do have to zig build and upload it, which means that here we need to udh cpc. We do need to compile the code that we want to run. Memcopy arguments have non-equal lengths. That's surprising to me. Because here are VB size. Oh, is it slice as bytes? Yeah, it is. My bad. Okay, so now he got a new vertex buffer length of 61440. Computer is so choosy, yeah. Which is good. We have like a new behavior here that kind of lines up with what we would expect. And what seems less good here, these logs don't seem good by the way. Allocating new vertex buffer of len 0. That seems bad. That definitely seems bad. So what the fuck is going on there? Sphero derv. Hello? Oh, source Linux. Sphero derv. So here, our param size is not set, probably in our upload. We forgot to set the size, which he's weirdly okay with. All right. So maybe our tests earlier that were checking if we had full white weren't really valid. Weren't really valid, but that's okay. I guess I didn't mean to close the virtual machine, but I did. It's a hard life out here. It's a hard life out here. UDH CPC, and then we zig build, and we try to SCP it over. And now it looks like we got a new vertex buffer of 58020, which seems maybe right, who knows? And I wonder if we can like look at the content of that. So maybe we just write out. We could do something like for I is less than VB size over 4. We do VBF32 is a float pointer, right? Then we can go through each pointer, and we can go through them in groups of 5. I think that makes sense. What are you talking about, man? If a log falls in the woods and no one starts to read it, does it make a noise? Oh, because of the lack of printfs here. Yeah. That's good one. So I actually want to go over 20 here. Then we can kind of iterate these things in groups of 5. And we can print the thing as a float. I think I actually still want this to be I over 4. And then I want this to be I plus equals 20 here. No, I plus equals 5 here. Yes. So we go from here to here. We increment in steps of 5. And then here I guess here we could actually do no condition. And then here we can still work with I. Line end. Do I plus 5. Then we go for I is less than line end plus I again here. We should be able to look at VBF32I and printf that thing. Like this, and then at the end of the line, we print a new line. Okay. Does that seem right? So there's like a bunch of bytes, divide by 4 to turn them into a number of floats. We iterate those floats in the inner loop, but in chunks of 5. Should be fine. Maybe. So what we're hoping to see is a bunch of like x, y, z coordinates in the range of like -1 to 1-ish, and a bunch of UV coordinates in the range of 0 to 1. That's what we're hoping to see here. And we will see if that's what actually happens. We will see. Instead we see nothing. Nothing. So what the fuck is going on there? Printf, cursor, and size. What if the number of floats isn't divisible by 5? It should be, though, in our case. We're kind of like matching the expectations on what's on user space. So I think in our case, it should just kind of work itself out if everything's correct. If not, then we have a bug and that's fine. Oh my god, fucking printf, man. All right, let's try again. Test app, dev DRI card 1. Cursor and size are both 0 here. Allocating a new VB of len this. Do we not set the size field? We do not, and that would do it. Oopsies, oopsie daisies. It's a hard life sometimes. Okay. There we go. That's not good. Oh. Yeah, this seems very much not really good. So cursor here, size here. So it looks like we read the right amount of data. But what we're seeing here is definitely not the vertex data that we should have uploaded, right? So there's kind of multiple ways that this could have been going wrong. Some are like on the vertex upload. Like we should check that in user space this looks okay, right? We're not really sure about that. We are not sure that in the Linux kernel it looks okay. Yeah, so there's a lot of places this could have gone wrong. So I think we just have to start bisecting. We just need to start bisecting. So let's start here. This is the easiest place. In the user space application, we should just go do the same thing. So for 0 to VB data len over 4, we'll call this, I guess we go over 20, line index. For 0 to 5, line lm index. And we look at VB data from line IDX times 20 to line IDX plus 1 times 20. This is the line. And this should be a U32 of F32 array. So we pointer cast this. And then here we just go line lm IDX. This should be the same thing. And then here we print a new line. All right, let's see if that is somewhat sane. This does not work, so we need to do stud mem bytes as slice, I guess. Like this. I think it's like this. We'll find out. Expected type this, found that. So can we like align cast this? And just hope for the fucking best? Hopefully the alignment works out. Nope. Can we align cast here? Maybe. Nice. So this is kind of the type of stuff we were expecting to see, right? All of these are like smallish numbers between 0 and 1, or -1 and 1 if they're on the left side. So that's good. At the very least, the data that we think that we're uploading is good data, right? So now we can go look at the kernel driver and check here if what we are uploading we think is good data. So here we could maybe just what's the best way to do this? What is the best way to do this? I guess we could look at vert adder. And we could just go like for int I equals 0, I is less than vert SG length over 4. Oh, we don't have floats in the kernel. We don't have floats in the kernel, which is a little annoying, right? So we can't really like float format print these things. But we could print them as floats if we break here in GDB, which I think is probably the play here. Probably the play. So let's ask QEMU to spawn a GDB server for us. And we can go, get in that with GDB with our run script. This should get us up and running. We wait for our kernel module to load, and then we break. We say LX symbols so that the GDB can figure out which kernel modules are loaded at which positions. And then we should just be able to be like, yo, I want a breakpoint like here. And then we run our test app. Should breakpoint, which he does. And can we just start like, fuck. Okay, we didn't get the virtual address, but the virtual address should be easy to get. SG vert just returns SG page plus SG offset, but it uses like fucking. Oh, it's like macros all the way down, which GDB isn't gonna be able to find. Fuck. What is the easiest thing to do here? Hum. It would be nice to prove something here. We could do this. We could just like get the vert address and then like force it to be used. Right? We could do this. This is a, like, we can do like a U8 star here. Like this. Recompile. Run it. GDB it. Get in here. And we can call, I guess we need to do our LX symbols trick here and breakpoint on the right line, which is here. And then we run test app dev DRI card1. Thank you very much. And we have now, oh, fuck off. No. That's so annoying. Okay, 372. Continue again. Oh, it's so fucking annoying. It's a hard life. It's a hard life. Oh no, are we hung? Oh no, we're not. We're fine. Okay. That's so fucking annoying, dude. Oh, it's so annoying. How do we fix this? I just want to know if it's okay, you know? What if we print them as U32s and then check that they're the same as the U32s in user space? What if we do that? Right, we're just like, fuck it. Type some U32s here. And then here we print out. These are U32s here, I guess. And we go for int I equals 0, I is less than SG length. I guess we actually want to do more like int I equals 0. Let me think. Num printed equals 0 here. For int I equals 0, I is less than SG length plus I. This should be over 4. And num printed is less than the size of the input. Right? We slap those two things together. Then we do something here. What? What? We go num printed plus equals 1, and then we print k vert adder plus I. I think that's right. And then we dereference it. And maybe we print them as hex here. Just kind of feels more natural if we're taking like the, we're trying to bit cast a float. It just feels like we should be printing the hexadecimal version. Kind of feels that way. Cool. Cool. And then I guess in here we should do the same thing where we print it with hex. All right. Let's fucking see it. Run it. We don't need GB anymore. Run it. Okay, root. We need to get the latest and greatest of our user space app. I guess. Okay, and so now it looks to me that there's a bunch of trailing zeros in here. But then, like, maybe that's just kind of running off the edge, right? Here we see that this is like F166FD, which matches this, 78 matches this, DE matches this, 00 matches this. So I think that this is actually correct. Which is kind of nice. Now, it's concerning to me that we are sending too much stuff. It's also concerning to me that there's a bunch of zeros kind of like just around. Right, like what's going on here? Oh, it's maybe less here. Hold on. Could have been less. Okay, yeah, okay, so there's occasional zeros, but like we see a zero next to F86000. So there is an actual zero there. So I think this is fine by like some metric of fine. It looks like the data in here is matching what we expect. So the question now becomes, why the fuck is that not making it over? You know? Because we're writing to the wrong output. The cursor is on the output side. I'm just a dumbass. Just a dumbass. Oopsie daisies. We were just adding like how far we've written into our array into like the current page input instead of the output. So we were just always writing to the beginning of the array a very small amount. Okay, so still doesn't look great, to be honest. So we are still not quite there. So if cursor plus read len here as well is less than the VB size, then we do DMA. Let's try that. There could be more bugs in here. Definitely could be. We're not counting it out. But, you know, we can always try again. Once again, it looks like not good. Here's what I'd like to do. I'd like to, when we initialize our array here, okay, so here we should break, first of all, when we do our initial allocation. Then I would like to also memset. This is like 0xff or something. For this much stuff. Right, I would like to see kind of how that plays out. And then here, let's make sure here that our VB cursor is going to uint 8s. We're casting our uint 8s to float 32s. We are always working from the beginning, which is fine though. So we work from the beginning, we work our way up. Over 4, yeah, it feels like that should be right. Feels like that should be right. But I guess there's some risk there, for sure. What did I even change this time? It was, I changed that I mem set the thing to 0xffffffff. So we want to see if all of this stuff is like unwritten memory or written with zeros intentionally, right? Wait, it just looks kind of right now? This is just correct now. So I must have just not compiled and tested at one point, because these are just correct numbers. So I think probably, I do not think. Oh, it was maybe this break changed actually, to be honest. This was probably important to try to like bail out of this switch case early, in the case where there was no data to copy. Yeah, that would probably do it, because then this was kind of like moving the cursor forwards after just reading like random fucking memory from the guest. Yeah, that would do it. That would do it. All right. So weirdly, shockingly, our time is up. That's kind of annoying. Because I kind of wanted to get way farther today. All we really did was upload data, upload model data to our host GPU. But you know what? I guess it was just a harder problem than I thought it was going to be. So what did we do? We allocated some new registers. We basically copied the same format that we used for frame buffer copying, where we allocate some chunk of memory in PCI space, or like some bar mapped PCI memory, where we can just like push addresses in. Those addresses are for vertex buffers. We added these ioctals to basically create a vertex buffer from user space, and map that shit and put so that we can like copy data into the kernel buffer. Then we upload that stuff by pinning those pages into memory like we did for the frame buffer and copying them over. And we had a bunch of mistakes along the way. But we're there now, so check it out. In the host, we have a bunch of floating point data. So tomorrow, we should be able to get in here and basically take all of this floating point data, upload it into an OpenGL context, and try to display it, and then work our way forwards. Just again, for context, I'm sure that at this point it's not very useful to show this, but we are working towards this. So tomorrow we are going to try to show this monkey head in our GPU, and probably from the straight front on. Then we'll probably try to texture them next, and which will require uploading texture data somehow. So we'll see how that goes. It should be very similar. But yeah, thanks for watching, guys. I had fun today. If you liked what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. 12:30 to 2 is like what we call happy hour, where we work on like maybe code cleanup or research or like small features that don't deserve their own YouTube video. 2 to 4 is like the mainstream segment. If you're watching on YouTube, you will be seeing this mainstream segment, but if you want to see the happy hour stuff, that is paywalled. So if you click the join button or go to Patreon, you can get access to that stuff. If you're watching on Twitch and you haven't been here before, this stuff will end up on a playlist in YouTube. So if you want to check that out, that's here under Demons of Analytics Graphic Stack. There's a lot of cool stuff in there. But if you want to see other projects, those are available as well. Writing a debugger, a kernel module to filter regexes, like a map that plans bus routes around city, QR code decoder. You know, there's stuff there if you want to go check that out. GitHub link in the Twitch description. This code will eventually end up under GPU testing env. We have been working on cleaning it up a little bit. We're not quite there yet. Like, subscribe, Twitch Prime, and a ball machine plug. Right, so if you guys want to add to the ball machine on the right, you can go to spherophoria.dev, and you can upload a WebAssembly module that I will be able to approve Like for example, like this is what my user page looks like. I've uploaded all of these ones. Somebody else has uploaded things like this funnel or this thing. So if you want to add to the thing, that is possible. Otherwise, I will see you guys later. Goodbye, YouTube and Twitch. Let's find someone to raid.